So this is a preview of a conference talk I've got coming up. So we don't normally think too much these days about what Unix means. In 2023, most Unix systems are actually running some kind of Linux, which includes, modern tools, modern commands that were just unthinkable when Unix hit the scene in the early 1970s. But here we are some, 50 years later, and Unix is still going on. And so I wanted to go back into Unix history and sort of demonstrate firsthand what it was like to use an original Unix. Now, to do that, I need to talk a little bit about history here. So the first version of what we would call Unix came out in 1971. That was Unix first edition, and that was the first one to run on the PDP-11 computer. The second edition came out in 1972, and that was the first version that included a C compiler, because that's when the C programming language was born. The third edition included features that we kind of take for granted today. And that was the first version that had pipes. And that's where you could take one command and send the output directly to another command. Before that, you had to output to a file, and then you had to read that file into another program. But now with pipes, you could string one command into the next. Also, later that same year was Unix 4th edition. That was really the first time people got to see Unix out beyond, much beyond Bell Labs. 5th edition was really meant for higher education, but 6th edition was the one where you started to see commercial licenses. 1979, things started to slow down a little bit because it's not really something that Bell Labs wanted to focus on in terms of operating system development, but this is where we got the Bourne shell in 7th edition. 8th edition was, again, really meant for higher education. 9th edition was never really released. It was kind of a conceptual release in 1986. And then 1989 was the 10th edition. That was the last version of Research Unix. Now, what was in each one of these versions? So the Unix first edition, which came out in November 1971, included a bunch of commands that we would recognize today. I'm going to highlight only a couple of things in here. nroff, by the way, was in this. And so nroff was the first program that would allow you to typeset text. Before this, there was another program that was known in the computing circles called runoff, and that was a program that got its name from I'm going to run off a paper, I'm going to run off a document. And it was just a quick way to format a document. nroff was meant to be sort of a simplified version of what runoff provided, and so that's why I got the shortened name nroff. Later, as we'll see, there was an nroff, and that was the new version of nroff. And even later, there was a troff, and that was when Bell Labs purchased a photo typesetter, and they were able to now do typesetted version of nroff. But this version also had a Fortran compiler. Obviously, that was Fortran 66, and of course, a basic environment. Unix 2nd edition, 1972, this was the first time that they updated nroff to now become nroff. And so we can actually start to write documents using a more familiar environment with nroff. Also, as I said earlier, this is the first version that included the C compiler. Now, I actually have a copy of the Unix 2nd edition manual, and so this is the cover page for that manual in 1972. And the table of contents shows you all the different commands that were available to you. I've only grabbed the first 2 pages here, which shows section 1 of the manual, all the different commands that you could run. Unix 3rd edition is what I'm going to show off, because that was 50 years ago as I do this video. And so that included the first C debugger. As I mentioned, also included pipes. And this is also the first time that they split off bin from user bin. User was usually mounted as a second hard drive. And so this allowed you to split the commands across core system commands and then things that were sort of more user oriented. Now, as we look at the manual for that, this is the manual from 1973. Again, this is the cover page, and you can see all the different commands that were available to you. Now, in this video, we're also going to explore nroff, and so that is part of the Unix 3rd edition. And to look at some of the what we're talking about in terms of emulating this old environment, what were people using to interact with Unix back at that time? Well, this is the PDP-11 that they were using. I think this was taken around the time of Unix 1st edition. And the teletype terminal is what Ken Thompson is using there. And that is literally a big roll of paper. And as you press down on these keys, it would type out on the piece of paper. And when the computer had output for you, it'd type it back out onto that piece of paper. And so that was the first terminal, a teletype terminal. Now, over time, you started to get electronic terminals, these video display units. Now, granted, this is a VT100 terminal, which is long after Unix 3rd edition, but I'm showing it only because it was probably arguably the most popular video terminal of its era. But in the early to mid 1970s, after we moved off of teletype, you started to get video display units, which looked not unlike what you're seeing here. And so when I do this demonstration of what Unix might have looked like 50 years ago, I'm going to use a video display terminal that looks something like this. Now, when we talk about a terminal emulator or a terminal window on your Unix machine, your Linux machine, this is actually what it's emulating. It's emulating a system like this, the old glass terminals. And one program that I like that actually does a pretty good job of emulating what it felt like to use a glass terminal is Cool Retro Term. And that's what I've got here. And so this is emulating a glass terminal. For those of you who are curious, if I bring up the menu here, you can see that I'm running in Apple II mode, and I'm running in full screen. And this is set up right now to have, just do an echo on columns. This is set up to be an 88 column display at 24 lines. And so why did I pick this? Well, one, I wanted to be zoomed in far enough that I could make it look kind of like an original terminal system. Those terminal systems were 80 columns wide and 25 lines tall, though usually the last line was reserved for some sort of terminal display or terminal status. So an 80 by 24 is closest that I can get to emulating an original glass terminal. And so 88 by 24 is pretty close. Now I'm running it in this Apple II because this is what gives me a font that is big enough that I think it'll show up well on YouTube. Now I've also set up my terminal to emulate a VT100, and the Linux terminal can all emulate VT100. So what were some things that people might have done on a Unix machine back at that time? And so one thing that a person might have done is to write programs and write documents. Well, we didn't have VI in this era. VI didn't come along until much later. And so the editor that everyone was using at the time was an editor called ed. And this is the line editor. And if you ever look into original Unix systems, this was used all over the place until VI came along. Now I'm going to use ed then to edit my my work here. And so if you ever want to see what ed looks like, this is it. So let's go ahead and edit a program, a Fortran program, and I don't have anything in this directory right now. Let's edit a new program in Fortran, and of course we'll do this in Fortran 66. Now I've got a Fortran 77 compiler on the system, and actually all it really is, I've got a an Fortran 77 shell script, which is really an alias basically to the GNU Fortran compiler, which will happily compile Fortran 77 and backwards compatible programs. So we can use this to compile, even though it's F77 and Unix Edition 3 used Fortran 66, we can still use this to sort of simulate the work that we would have done back then. So let's go ahead and edit a program. So the program I'm going to edit here is, let's do clear screen, we're going to write a simple Fortran program that will do some trajectory data for us. And so I was a physics undergraduate, and this is something that I would have done all the time. So I'm going to do a new program. I'm going to call ed, and then I'm going to name this program drop.f. And there's no file here yet, so as I save this file later on, I'll be creating a new file. So let's go ahead and start our prompt, and so I'm going to do a capital P, and that will turn on the prompt. Otherwise, you just kind of have to know where you are. So the prompt here is just a star, an asterisk. And so let's go ahead and since this is an empty file, let's go ahead and insert some new lines. So Fortran is column sensitive, and so you need to be careful what column you're in. So 1, 2, 3, 4, 5, 6. So now I'm in column 7. I'm going to use call this program drop. And what are we doing in this program? Let's do some documenting here. So let's make a comment. And so this is going to simulate trajectory data. And so the formula for trajectory is x as a function of time is x0 plus v0 times time plus 1/2 a t squared. And so when you do exponents in Fortran, it's the double star. And so that is the trajectory data. But if we make the assumption that x0 is 0 and that v0 is 0, this is typical for some sort of experiment where you'd want to get trajectory data, basically how long does it take an object to fall. And undergraduates who do this all the time to kind of measure the acceleration due to gravity. And so if we make that assumption, then what we're ending up with is x over any value of t is going to be just 1/2 a t squared. Now, if we turn that around, we solve for t, then how long does it take when you drop any kind of object? Let's say just in an undergraduate lab, it might be a steel ball. And so if we solve for t, then I can do some simple math here to say that t squared is going to be equal to 2x divided by a, or in other words, t is going to be equal to the square root of 2x divided by a. And so that's what we're going to be doing here. We're going to be doing a reverse trajectory here. We're going to basically simulate how long it takes some object, let's say a ball, to drop from different heights. And when I was an undergraduate, we'd use a photo gate, and that would give us some very accurate timings for how long it would take an object to drop from different heights. And we would probably move this up at, let's say, 10 centimeter heights or something like that. And so that's what we're going to do here. We're going to simulate that. And so we're going to do 1, 2, 3, 4, 5, 6. I need to have some variables here. So we'll do a double precision. And then there's, we need to measure certainly x, and we need to have t, and we need to have the acceleration due to gravity. And so I'll just do that as g. And then we probably should establish g as being 9.8. And then we'll start x at 0.0. And I should have looked up before I did this video if Fortran 66 had a do loop, and I can't remember if it did. I think it did, but we're gonna make our own loop. So let's do this. I think we'd want to put our start of our loop here, and so we want to calculate that for that height, t is going to be equal to the square root of 2.0 times x divided by g. And if that's right, then I should be able to print out the values of how high we dropped it from and then how long it took to reach the ground. So that's what I want to do there. And then I want to now increment. See, I don't have a do loop. I'm doing this without a do loop. So I'm just going to increment x. And so we'll say x is x plus 0.1. And then we're going to say as long as x is less than, let's say 1.05. I could do some other value, but like 1.01 or something like that. I don't want to do like less than 1.1, just because I don't want there to be like drift in my my floating point. So I always can learn as an undergraduate, make this, if you're doing a less than of a comparison of a double precision or a real value, you should just go beyond, slightly beyond what you're looking for. So that's what I'm going to do there. It's just slightly beyond 1 meter. And then we'll, if it's less than, then we can go back to go to 10. And if it has now exceeded 1 meter, then we can go ahead and end the program. And so that should be correct. And so I'm going to put a period in its own line, and that tells Ed that I've reached the end of my file. And I'm going to go ahead and write that to disk because I don't want to mess anything up. And let's look at the listing of my file. So do a 1, comma, and then the end of the file, and we'll say number every line. And so that tells me that that is a 16-line program, and you can see the what my program looks like. Now it's added a tab in there from the left, and so now everything isn't left justified neatly. If I want to do that, I could do 1, comma, 16. That's the last line, and then P to print it out, and then I can see my full listing. Now, I already saved the file, so let's go ahead and quit. And so if I compile that, let's do, in my case, the program's called F77, and we're going to save that as drop, and then there's drop.f. And no errors, so that's good. And so if I just run drop, then there it is. So going at 0.1 increments, dropping, let's say, a ball, not a surprise that dropping it from 0 gives you an immediate, it hits the ground. And then going up, that's how long it takes for an object to hit the ground. And so if I were an undergraduate student, this is a typical program that I might write. Let's write a document that describes this. And so let's start a new document. Let's do clear. And so let's start a new document. We'll do it in the ME macros because I like to use that. Now we don't have EQN. That's the program that would appear later for nroff to do equations. And so we can't do equations in this, but we can directly format a document to kind of simulate equations. So we're going to do an ed of a new file called well, we'll just call it about.me. And there's no file there, so when I save it, it'll be saving a new file. Let's go ahead and create a prompt. And so as I insert some new text, let's, if you watch the other video about how to use ME, you know how to do this. And so what we're going to do is we're going to create a title page right up at the top. I also like to define my headers. And so let's say I wanted to have at the top, I'll just put in left and then center and then right, just so you can see a demo of how you'd create page headers. And I can also create a page footer, and that would have, let's say, left and then nothing in the middle. So I'm going to do 2 single quotes there, and then we'll do a page number on the right, because anytime you use a percent in a header or footer, that'll insert the page number. And just so we can see that that's actually left in a footer, I'll actually just say footer, and then there's our page number. All right, so that's what we'll see there. And then on the cover page, I'm still on the cover page, the title page. Let's go ahead and center some lines. And so we'll go ahead and center, let's do the next 3 lines that get outputted, and blank lines don't count. So we're going to space down by, we'll do 3 inches of space. And then we'll put in a title, which I'll make bold, and I'll say simple trajectory data, and then we'll space down an extra 2 lines, and we'll put in the author, so Jim Hall, and then we'll space down an extra line, and then we'll put in the date. We'll just say date. And so there I've got 3 lines of output. So I've got the simple trajectory data is 1 line of output, and then my name, and then date. So now that's the end of the 3 lines that get centered with .ce. And so now that I've done that, I can now do a page break or break page, BP, and now the header and footer will now take effect. And so let's also, I like to now do a line spacing if I was an undergraduate student of 2. And now let's go ahead and just create some section headings. Now I don't need to number these because I'm just going to do a simple document. So we'll do an unnumbered heading .uh that says introduction. It doesn't have to be in quotes since I ended up writing another word. And then we'll do a left block paragraph, which I personally remember LP is also a leading paragraph, because if you look at any textbook or any formal book, the first paragraph after a section heading is block paragraph to the left. It's not, doesn't have that temporary indent. .pp would give me a temporary indent. .lp does not. So I'm going to do a leading paragraph after that. I'm going to say this program or this paper discusses a Fortran program to simulate the simple trajectory motion of an object that has been dropped at different heights. And then we'll do a paragraph in here. And we'll say the math. We'll say a derivation. We'll say assuming the equation of motion. And so this is where we get to be a little tricky here. So we're going to put in, now I don't have EQN, which is the program for equations in nroff, because this is still nroff. We don't have EQN yet. So I need to do this on my own. So I need to create and turn off fill. So I'm going to do NF. That will turn off filling, no fill. And now I'm going to put in the equation of motion. So I'm just do a couple of spaces in here. So basically anything between NF and the next FI, which is what I'm going to do later on, I'll do an FI, and that will turn filling back on. Anything between NF and FI will be printed verbatim. So I'm going to put in a couple of spaces here just to kind of center it a little bit. And we'll say X as a function of T is going to be X0. Now I'm going to make that subscript in a little bit, but that's okay. I'm going to leave the 0 here for now. Plus V0T. And again, I'll make that 0 on the V as a subscript in a little bit, but for right now, we'll leave it as a placeholder. Plus, and I'm going to put a fraction in here, and I'm going to, I'll put the 1/2. I have to draw that on my own. And to keep, I would normally put like a hyphen or something to kind of indicate this is a fraction, 1/2. But I don't want it to look like a minus symbol, so we'll use an underscore. And so there's our placeholder for the 1/2 fraction, and then A, and then T squared. And so I'm going to make the next line, I'm going to make a subscript or a superscript for that. And so I don't need to put in the 2 right now. Now let's down here on the next line, let's now do the subscripts. Let's put in the placeholder for the subscripts. And there's our 0 and our, and then our 0, and then we'll do filling back on. Now we'll stop editing there. Let's save, by the way. And what line number are we on? This is 23. So 23 is the .fi. And so if I back up a little bit, then let's print lines 20 to 23, and we're going to number them just to kind of see what's what. And so 21 is the line that has my equation on it, and line 20 is the one that has the .nf on it. And so let's do 21, and we'll print that one out without any tabs or line numbers being put in there. So that's exactly how it appears. And so 20, I'm going to append to line 20. This will now go between 20 and 21. And now let's do the 1.5. Oh, I forgot to put in the 2 for my fraction. So we'll have to fix line 22 in a minute. And so let's go ahead and put in, I just do spaces, and I'm going to put in the 1, and then there's the 2 to make the squared. And then I'm done making that edit, so we'll do a period. And let's go back to 20 to the end of the file, and we'll print those out. Okay, and so line 20 is the NF, 21 is the 1 and the 2, 22 is the one with the equation on it, and 23 now is the zeros. And so I want to change line 23. And so I'm going to go over here and put in the 0 and the 0, and then there's my 2. And then let's print out line 22. And so let's go ahead and get rid of those zeros. And so we can do this. We can say starting at line 22, but then also ending at line 22. We're going to swap any zeros with a space. And let's do a global. And so that should be what I think I just did the right thing. So we'll print out the rest of the lines here. 20 to the end of the file, print those out. And yep, that did what I needed to do. So I've now created a formula that looks like the equation of motion. X is a function of time. X0 plus V0 t plus 1/2 at squared. Since I don't have the EQN program to make equations for me, this is the closest that I can get on a plain typewriter device. By the way, just to remind ourselves where we are here, let's back up a little bit. So 15 to the end of the file will number those lines here. And so then 24, I can now start appending after 24. And then I can say dot LP, because this is just going to be an assumption. Well, let's do a full paragraph. Dropping an object with 0 initial velocity and assuming we measure the height, the distance dropped after time, and we'll do this as an italics, time t. We can simplify the equation to, and then we'll just say here, dot, well, let's finish editing here real quick. Let me back up a little bit. So 24 until the end of the line, end of the file is that. So I want to actually put in initial velocity. So I'll do 26 append, and I'll put in italics V0 there. All right, so let's do the, should be now 31 should now be the last line. We'll do 30 comma the end of the file. We'll number those out. And yep, so we can now simplify that. So 31 append. We're going to then do a, I don't want to do that. I want to, where was my equation? How far in did I do my equation? So we'll do 20 to the end of the file, and we'll print those out. And then it was, there we go. So 31 append, because that'll be the last line. I can now say, looks like it's, I did 5. So xt is going to be just 1/2 at squared. So there's our bar for the 1/2. There's our a. There's our t, and then we can put in the 2, and then we need to turn filling back on, and then I didn't track where I was supposed to be. So 28, 29, 30, 31. So 31 append, I want to turn filling off, so no fill. And then I can also now insert the 1. And that's the 1. And then let's go ahead and print where we were again. So 30 to the end of the file, numbered. And then I can say 36 append. We can to measure the time required to drop a distance, put in italics, x, can be calculated as, and then we'll do another one where it's no fill, and then we'll just say 5. It's going to be t equals the square root of, it's going to be 2x over a if we do that math, right? So that was, we need to have a division there. We'll have to put the 2x, the a in there. So there's our square root, and then we'll up here, we'll do the a on the bottom, and then we'll turn filling back on, ending our edit. And so if I do a 36 to the end of the line, print it out, then if that's 36, 37, 38, 39, 40, 41, if I do a 41 append, I can now put the 2x on top. All right, and so I think you can kind of see where this is going. So it's kind of an interesting little file. If we just write it back to the disk, and if I do quit that, and then I can view that file with more of about.me. So you can see I've got my title page up there, my header, my footer. I've centered in the title, created a new page, and then I have the double spaced, and then I have a section heading, and then some paragraphs. And so the paragraphs also have some equations in them, which I'm just double checking look correct, and that I haven't messed anything up. And so that looks okay to me. And so now if I were to run nroff on that, nroff with me macros, and the file was about.me, and then I can run that into more just so I can look at it one screen at a time. And so that the first page was blank because that was the 3 inches that it was trying to go down. So there's my title, and then the rest of the blank page for page 1, and then we should be on page 2 over here. And there we are, double spaced, and it looks like I need to single space on my on my my equations. We can fix that, but you can see otherwise the rest of it is looking pretty good. Actually, let's just go ahead and take out the there's our footer. Now let's go ahead and just take out maybe the that line spacing. So we'll do add on about.me, and it was somewhere towards the top. So it was something like, let's start at 5, and we'll go down to 15, and we'll number those lines. And so there it is. Looks like 12 we'll need to get rid of. So we're going to say 12D, and that'll delete line 12. And so if I go back to, I forgot to turn my prompt back on, so I'm just typing into the air. And then we'll start at line 10, which should be the date instruction. We'll go down to line 14, which should be the this paper discusses, and we'll print those out. We'll do number, right? And so now I just verify that I got rid of what used to be line 12, which was the line spacing of 2. So I can write that back to disk. And now I've created a Fortran program, and I've now written a document about it. When we actually process this nroff file, it'd be nice to actually verify what our line numbers are, so we don't actually have a program to do that. I would normally write an awk script to do that. It's very easy to do an awk, just to put line numbers before each one, or these days the cat command has that option, but in Unix 3rd edition we didn't have the ability with either of those programs. Awk didn't exist and cat didn't have that option. So let's write a simple C program that will put line numbers in front of each line. So we'll clear the screen here, and we're going to do ed on a program called linenum.c. This file doesn't exist, so it's going to be a new file. Let's go ahead and start a new one. Now, I'm not going to be able to write old original C on here, so we'll just do the best here that we can. So we're going to insert, we're starting here by saying include standard io.h, and then I'll need to have a program in here, int main, and then that will take 2 options. So we'll read the command line. So int argc, and then char argv. And then I need to be able to process the command line. So I need to do int I, and then I need to open some files. And so we'll do a file of p file. That's our pointer to a file. So what I do here is I'm going to scan the command line. And if no files, then read from standard in and print to standard out. Otherwise, open each file and process them. And so we're going to write a function in a little bit that will actually allow us to process these. But for right now, let's go ahead and check how many options we have in our command line. So we'll do an if argc is equal to 1. That means that we only have the argv 0, which is the name of the program itself. That means we don't have any options on the command line. So we'll just say, okay, if that's the case, then we'll call the function linenum from using standard in as the input and standard out as the output. And then we can be done with that. Otherwise, we'll just say else. we're going to do a for loop of I equals 1. And then as long as I is less than the arg count, then we're going to increment I after each iteration of the loop. And now we're going to open the file. So we're going to save the pointer to the file using fopen on argv I, and we're going to read that file. And then if we, so we'll say if the p pointer to the file is null, that means we couldn't open it. And so I'm going to do fprintf to standard error and say cannot open file. And then we'll just name the file as argv. Otherwise, now we've got an active file pointer. It's correct. And so I should be able to call linenum, my function that I haven't written yet, using reading from p file and then printing the standard out. And once I've done that, I should probably close the pointer to the file, and that allows me to go on to the next entry in the file, right, in the command line. And so that should be the end of my for loop. And that should also be the end of my else block, and then the program can happily return back the operating system. So I'll say return 0. All right, so let's save that before we get lost. Now I need to write a function that will do linenum, and let's put that before our main function. So let's just look at what we got here. 1 through 5 will number those lines. So I want to insert after line 1. We'll do append. And so I'm going to put in a blank line, and then we'll write our function. So the function is a void function, doesn't return anything, and we call it linenum, and we have a file input and a file output. And how do I need to read this? I need to be able to read this as I need to be able to read it. There are different ways I could write this function. I could actually do it a very efficient way in terms of file I/O, where I'm just reading in things to a buffer. I could do it another way, I guess, where I could read it line at a time. Here I'm going to do the very simple, naive way, just because I'm not doing an algorithms video here. This is just a video to demonstrate how to use old Unix, and so Ed is really the shining point here. So let's just do a very simple function that reads characters one at a time from the file, and then after every new line, it prints a line number on the next line. So that will tell us which line we're on. And after every 66 lines, because nroff should generate 66 lines at a time, because if you watch the other video, you know that nroff generates 66 lines because a printed page was 80 columns wide by 66 lines tall. After every 66, we'll have to reset the number back to 1. So we need to have room for a character that we're going to read in, and we're going to do a line number. We'll just call it line, which we can initialize to 1. All right, so I guess we should probably start by doing a printf on, we'll space this one out to 2, of the line number, and then we'll do a colon, and then we'll immediately print out the rest of the line. So that's the line. We'll increment that after we're done printing it. And then I think I can go ahead and loop the file now. So we'll do a do. And what we'll do is we'll now read ch using fgetC from the input. Now, what that will do is that will return a character unless it's the end of the file, in which case it'll return EOF. So we need to double check if the character is not EOF. Now we can actually do something with it. And so what we're going to do is we should print it out first, because if it's a new line, we'll want to print after that. So we'll do fputC, and that should be the character we want to put out and then where it is going to go. And then we'll ask if the character is a new line, then we're on a new line, so we should print out the new line number. And so we'll just repeat what we have up above. So printf, and then %2d, and then line plus plus. And that is that. And we'll do the 66 back to 1 in a little bit. Just want to make sure this works. And then that should be that. And then I have my do loop, which I'm ending as while ch is not the end of file. And that should be it. And so I can now save that. And I should be able to just write that back to disk. Let's compile that. Let's check it. So let's do a cc of save the output of linenum of linenum.c. And that looks right. And so if I were to actually process, if I were to do an nroff using me macros of about.me, and then put that into linenum, and then view that through more, then there's my line numbers. And I didn't set it so that it would reset it back to 1 after 66. So 67 is actually the first line of page 2. And there we are. So now we're up to 100. And so that looks like it's working. So I'm going to quit that. And now if I go back into the linenum program, let's go and find that that loop. And so where it was sort of towards the, it was in that function. So it was somewhere after line 10, and we'll go up to line, I'll go up to line 30, and we'll print those lines out. Okay, so there it is. So I'm going to say, let's do line 15 to line 20, and we'll number those out. And so that looks right. And so after I print it out, let's nest it inside. So we're going to do an 18 append. Let's do 18 print just so I can see where it is, because I want to make sure my indenting is right. So we're going to do 18. We're going to append after that. And then we're going to put in a blank line. And then we'll say if, now that we're done incrementing line by 1, that happened on line 18, if line is greater than 66, then line should get reset back to 1. And that should be the edit. So period will stop my append. We'll write that back to disk. We'll end it. And we'll do the compile of sending it to the output of linenum of linenum.c, and that looks right. So now I can do nroff with the me macros of about.me. I will pass that through linenum, which is in the current directory, and then we'll pass it into more so we can see the output. And so there's my blank lines on the top. There's my title page, which is 3 inches down. And then there's the rest of page 1. And then you can see that now on page 2, it starts with line number 1. There's my page header. Now I didn't do, page offset to create a left and right margin. That's easy enough to do. But since I've gone back to line spacing 1, you can see that my equations are showing up right. So that's good. And it should be all the way down to 66 lines for page 2 before it is now done with the file, because now remember it ended with every time it hits a new line, it now prints a line number in the next line. We can go back and fix that if we wanted to, if we really want to get rid of that trailing 1 colon. I don't really feel strong enough to do that, so we're not going to do that. But what we just done here is we've now created a Fortran program. And we wrote a document about it using the about.me, using the me macros and nroff. And we wrote a C program, a very simple C program, just to put some line numbers on there so you can see the output. And so that is, a typical use of how you would use Unix 50 years ago, and we used the ed editor throughout using these very simple commands. So what did you think of this video? You'd like to see other videos like that? Let me know in the comments below. Visit our website at freedos.org. Join us on Facebook, follow us on Mastodon, and consider supporting me on Patreon. Thank you.